Okay, so coming back from the pub, let's make this half an hour. I'm going to set a timer. I hope you do not get distracted. I'm just going to set a timer of 25 minutes. Let's keep it nice and short. So, I think what I've decided is we have a fixed number of instructions that belong to one set. That makes this an enum, not a trait. We may add more instructions, but they're still a fixed set as opposed to anything that we need to be able to do a thing. So each instruction is going to be an enum. The side effect of an instruction is to jump forwards a number of steps. Now, I've been rereading. I think the idea is that every different command, every different instruction, has exactly one number of parameters, but I'm not sure. Because obviously you could add 2 parameters, or you could add 3 parameters. So actually, I guess it's going to depend on the number of this, right? So no, we can't assume that. So the first thing I'm going to do is I'm going to, in a very unrust-like way, I think. I'm kind of tempted to get completely rid of this. I am going to get completely rid of this. I'm going to set a getter and I'm going to make a getter and a setter. Right, so fun get mem or load mem takes ref mute self. No, it just takes a reference to self, doesn't need to mutate it. And it is also going to take an address, which is a usize, and it's going to return, so memory is a vec of but actually so I was going to say this is going to deal with it being a number. For now, let's return a ref tick a stir. We're already generic over lifetime tick a. So what this is saying, so I want this to be an explainer, is that we are returning a reference to a string slice. So if we have this vec here, okay, our memory allocation looks like this. So we've got on the stack, we've got vec, which contains 2 words. So it contains, let's do it like that. Vec contains 2 words. It contains a location and a length, more or less. And then down in the heap, which apparently I've used equals for, we have some random location that gets the string 01002. Let's assume it's the one above. The next location has 3, next location has 4, and the next location has 5. So it's this vector. That's what our memory looks like. And let's say that this is address 0. So our vector actually looks like 0 with a length of 1, 2, 3, 4. That should be 5. So this is what the actual data sitting on our heap. These are usizes, which in this case will be U64. That is the word length of our compiled target. So then we're going to say, well, we also have this, let's call it S. Now S has a type of a ref stir. Okay, so this is also going to be some location and some length. Right? It's just another smart pointer. And in this case, let's say it is going to be 1 with a length of 2. Okay, nothing else, that's the heap, nothing else goes on the heap. Anytime we evaluate this, it's going to come back as 3 and 4. We can only do this so long as this vec is still valid and it's still in that location. Well, location doesn't matter because it's going to point to this, but we can only do it so long as this data is valid. Rust cannot always know that this data is going to be valid. It can't always work that out. So we are going to tell it that we are going to have some lifetime tick A. So lifetimes of the tick. A is just, this could be tick ginger, it could be tick C, it could be tick life. The only special one is static, as far as I'm aware. And by default, we start with A. So some lifetime A, and we are going to return a reference, okay, that lives as long as whatever the lifetime of A is. And actually, the lifetime of A, right, is the lifetime of self. Okay, because what we are referencing specifically is this vec here, and this vec here itself has a lifetime of A. These are different A's, by the way. But this reference that we're returning, right, is one of the items of this vector. It can only last as long as this vector lasts. Right? It is only valid as long as this memory is valid. Which in this case happens to be the lifetime of self. If we get rid of self, that memory goes away, and our string reference is no longer valid. In actual fact, I want to return a result of reftick string and error. And the reason is that we might ask for an address that is off the end. So we're just going to do self memory get, and yeah, OK or. So OK or. So get itself returns an error. So actually, we could stop there. Sorry, that's going to return an option, not an error. OK or is going to map our option to a result, and we're going to get embedded memory just fine. So far, so good. And store mem is going to be our opposite one, which is now going to take a mutable reference to self. We don't actually need the lifetimes now, because we aren't going to return something that has a lifetime. We're going to take an address with a usize again, and we're going to take a value. Ooh, our value is... Oh, okay, this might be a small problem. So the only way we can do this... the issue is we are taking something which is a reference to a string slice. We can only do this if someone somewhere owns the string that this is a slice of. Well, if under run instruction I decide to let value be equal to the string slice of 7, and then I do self dot store mem possession of 4 and value, this string slice exists from here and it goes out of scope here. Nothing owns this string slice after this point. So this should be a problem, because we're going to reference something that's now no longer in life. Let's get rid of you for a moment. Okay. Compile failure. Where are you unhappy? You're unhappy down here. That brace closes that, and this brace closes the import block, no? Ah. Okay. Ooh, you don't like that. Expected a result, ref tick A, got ref. Okay. So get returns a reference to whatever it is that's in there, which is already a reference. So we've now got a double reference. So we are going to map. I think map will only take... I don't want map, I want and then. So map takes an option and returns an option, and then takes the thing inside the option. So it's the function we're looking at. So the function here is a function once, generic over t, and it returns an option u, which is not one, I did want map. Okay. Yes, so this map is going to be applied if it's a sum, and if it's none, it's just going to be none. So if it's sum, it will take the value out of the sum, it will put it through our function once, which returns some other type, and then it will wrap that other type back up in an option. And what we can do is we can say we've got a reference to S, and yeah, that's unhelpful, and we're just going to return S. Okay, so what we're saying is the thing you're giving me is a ref S, which in this case is ref. Just return me the S, which is just the ref stir. Okay. What don't you like about that? You don't like that because it's not an error. String. Cool. So to owned is going to take a string slice and turn it into a string. Well, to owned will take any borrowed value and turn it into an owned value by well, as usually by cloning. So in this case, it's going to take a string slice, turn it into a string. So far, so good. Okay, so I need to go check Vec because it's is it acceptable for this function to insert off the end of the vector? No, it's not. So we don't want to append. We don't want to insert. We want to mutate. So I don't want to do swap remove. So maybe there is no inbuilt function for what I want to do. Because I don't want to insert, I don't want to extend everything to the right. I don't want to append on the end. Is there a swap? Split. Swap, okay. So in dref target there is a swap which swaps two indices, so that's not what I want. I think I might have to actually go and check. Okay, let's say I'm going to have to check. So if self memory len is less than, so len will start at 0. If I have a vec of length 2, I can go to an address of 1, so it must be less than address. So let's go the other way around. So if it's greater than or equal to, we'll do an early return. Error of invalid memory address to string. To string and to own in this case do exactly the same thing. So. And you don't like this because missing nails. Okay, that's fine. Otherwise, self memory, and we're just going to straight up go with the address is value. And we're going to return an empty OK to say that we've done this correctly. That's a string. And it's error. There we go. Right, yeah, okay, so here's the issue. So these lifetimes are not the same, right? This cannot be true. I'm going to tell the compiler that it is, but I think this should fail later on. And maybe it won't. Maybe I just don't understand lifetimes. What I'm essentially saying is this value has the same lifetime until it expires, right? This doesn't need to be true for lifetime earlier. This is only from the point this function is called. This reference will be valid until whichever one goes out of scope first. Either self or address. Whichever one goes out first, this lifetime tick A ends. This reference is no longer valid. Whoops. I mean, I don't think this should work, but let's see what happens. So the problem is, if I were to have some function that takes a reference to self, once this function returns, the value being stored the reference being stored should no longer be valid, right? Because this goes out of scope. In this case, this specifically, because I've typed it, has a lifetime of static. So what I would actually want to do would be something like fun something takes a ref mute self, and it takes an s, which is a ref stir. In fact, let's take nothing. Let's show what happens. Yeah, okay, let s be equal to some string. Hello world. Okay, so this now no longer has a static lifetime. This value goes out of scope as soon as this is dropped. And then we are going to do all that. There we go. Lifetime may not live long enough. So we're storing a reference, and we're saying that reference is going to live some period of time, but that reference is invalid as soon as this function exits. Because there is no garbage collection, S just gets dropped. Bye-bye. And that is because I've said that these lifetimes are the same. Now, even if I said these lifetimes are not the same, okay, that's not the function I wanted to be in, this is the function I wanted to be in. If I said this is B, and I said this is generic over B, lifetime may not live long enough, again. And I can add that bound, so B to K means that B outlives A, okay, which is a requirement for this to work. So all in all, basically, this is just a lot of video saying that because of lifetimes, I can't do this. What the compiler is saying, by the way, this is stopping a class of error whereby I have maybe it's not a nil pointer dereference. I've got a pointer to memory that's no longer valid, right? Something else could be in there. It could have been overwritten. It could be reset. Fundamentally, the compiler is stopping me referencing data that is no longer correct, because the compiler knows this is being dropped at some point, and it's being dropped before we stop looking for it. And there are a couple of ways around this, but fundamentally it's a problem with how I'm storing memory. So what I could do, and possibly the easiest way to do this, is to say, instead of this being a vector of references, there's actually no need for this to be a vector of references, right? This is the memory we own, and we should have full control over it. So either I make it a vector of string, right, which is fine, or if I definitely really wanted a reference, I'd have a box refster. I still need lifetime print. This might actually not get around it, because fundamentally something still needs to own this. So box owns the data it's in. So what this now looks like is, so this was what we had before, when we had a vec of ref to k. Now we have a vec of at position 0, I'm going to put positions in. It's a pointer to position, let's call it 7. And then in position 1, we've got a pointer to 8. It's a bit more complicated than that, but a box is fundamentally a pointer. It's a smart pointer just like the rest. 10. And so positions 4 is just null, all the way up to position 7, which now contains the actual string 0, 1, 0, 0, 2. Oh. And then 8, and so on would be 3. Yeah, and then 4 and 5 in 9 and 10. There's no reason to do this. This is entirely pointless. So let's just save all the headache and say that we have a vec of string. We no longer need to be generic over some lifetime. We will still return a refster. Why are you unhappy? You don't need it, okay. And so this map can go away. Okay. No. Expected refster. Oh. Okay, so we do still need a map. I think when I went over strings, I did ignore the fact you can have a reference to a known string. You happier now? Have I missed a character? Stop giving me a type annotation, that's actually quite unhelpful. Oh, I've added in that. There we go. I no longer need lifetime here, and this doesn't need to be generic over tick B. And the value now is going to be a fully owned string. And remember, the reason we're using strings is because I need, all the memory is a homogeneous type, and if there is a leading 0, I need to know about it. If we convert this to a number, we get rid of any leading 0s, we don't know what was that. We can't go through and process this vec into an enum. We can't have enum memory of an instruction. Instruction's a bad name for it. Okay. An instruction which has an enum instruction inside and a value which is of type isize. We can't do this because at any given point we might overwrite. Right, we've got this vec 0, 1, 0, 0, 2. Well, that might end up, let's say the memory after this looks like 7, 9, or whatever. This one might end up, the instruction point is going to move to here, and it might end up putting a valid instruction here, and we'd have to reparse our entire memory set again and be like, well, hang on a second. Is it a 7? And we'd need to check the output of every instruction and go, is this a valid instruction that we're putting somewhere in our memory, or is it just some character? And it's much, much easier to do, well, it's some character, and we're going to assume that every time we come to something, it's going to be a valid instruction. We won't actually make that assumption later. For now, that's basically what we're saying, because Advent of Code is well formatted. So if it's not a valid instruction, it's because we fucked up somewhere. And by we, I do of course mean I. So now our get is going to return a reference to a string, and we're going to take our reference to a string and turn it into a reference, or a reference to a string slice. This here produces an option. That's 25 minutes. Fuck me, that went fast. And then we're going to map our we're going to take our option and turn it into a result. Okay. And then when we store memory, we're going to take an own string. We're not taking a reference to a string, we're taking an own string. We're going to consume that value. It won't be available to whatever called store mem once store mem returns. We are going to check that we are within length, because we don't expect, within the bounds of advent of code, we don't expect the program to extend itself. It may well do, and now I say it, advent of code extending its own program, perfectly valid thing for it to do, but if we hit this when we run it, then, well, invalid store memory address, invalid load memory address. Once we know we're in our memory range, we'll just set the value and we'll return OK. And this empty OK is a Rust sort of shorthand for, we're not going to return you a value, but we're going to tell you this worked. And we still want to be able to return an error if there was one. But if there wasn't, just an empty OK, everything worked. Right, well, we're stopping there. So the things to do now are going to be parse instruction. And I'll just briefly... it's going to take a reference itself and return a result. Yeah, okay, that's fine. And what it's going to do is it's going to load instruction pointer, or load memory at instruction pointer. Check num chars, and that's the value to move instruction pointer by. Split into param mode and opcode. Now with my enum instruction, this can go away. Add is just going to be a vec of size. So yeah, okay. So it needs to check parameter modes and get values. Create instruction with parameters. Parameter values. That is it, and then return. That's all it's going to do. It's not going to run it. It's just going to go find it. And the reason for this is so that we can test this easily. Okay. Half an hour's up, so time to leave it there. Hopefully you've kind of seen how lifetimes work, and how lifetimes, whilst they can look like a pain, are actually doing something quite useful and stopping us doing really stupid stuff. Let's just get rid of all the compiler errors. Something can go as well. Lifetimes can be quite hard to work out, and it's one of those things that every time I read it and do exercises, I go, yep, okay, this makes sense. And then 30 seconds later, I go, wait, what is that? Wait, what? Fundamentally, lifetimes do not control how long something lives. It is simply because the compiler cannot definitely for sure work out that something lives long enough, and you are going to tell the compiler, hey look, this is going to live as long as this other thing. I have checked this. Kind of trust me, bro. That doesn't actually affect the lifetime itself. If the value is going to go out, if the value is going out of scope, it's still going out of scope. If the lifetime ends, the lifetime ends. Setting a lifetime won't change that. It's just telling the compiler where the compiler cannot work out itself, hey look, I promise, I've checked and done this. Hopefully next time we'll actually do something. And I hope you didn't get too distracted.